Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
Today we're going to talk about DevOps. We're going to see if we can define DevOps, investigate if DevOps really matters, and brush up on some of the ways we can improve our own DevOps processes.
So what is DevOps? And maybe if you can define it in your own words or just like talk about some of the important elements.
I like to use Donovan Brown's definition. DevOps is the union of people, process, and technology to enable the continuous delivery of value to customers.
See, I was just going to go with a different name for ops.
Yeah, but it's more than that, right? It's the merging of development and operations into delivering the applications quicker and more effectively, right?
I mean, it's supposed to be.
Yeah, no, I really like Donovan Brown's definition. And I really think there's sort of like two parts to it that really stand out to me. And the first one is really the focus on sort of the union of people, processes, and technology. I think kind of what's critical about that is the DevOps picture is really about uniting people groups and uniting processes, making sure the processes themselves and the technology itself is all sort of working together. And then you're also working across groups so that the processes aren't fighting with the people and people aren't fighting with the processes, so to speak. And I think the order matters. I think technology is there to serve the process. If you're using the wrong technology because you want to, use one that fits your process and pick processes that fit the people, that fit the people's needs. People shouldn't be serving processes or technology. It should be the other way around.
Yeah, and effectively, it's all in the guise of trying to deliver value to customers, to clients, to end users, right? We want to focus on the value that we can deliver.
Yeah, and that's that second part, enabling the continuous delivery of value to customers. The focus is on the value to the customer, and that means removing anti-value from the work, or bugs or things that are going to kind of the customer is going to receive that it's not going to get value from, but enabling and sort of removing those roadblocks and restrictive. I think it's interesting, like to use the word enable there, because a lot of times we sort of forget that everyone wants to be delivering that value to the customers, and really it's just about DevOps is about sort of like ironing things out, smoothing things, oiling things, greasing, kind of removing that friction, and it's everyone wants to be delivering that value, and it's a matter of like getting everyone on the same page, and all the technology on the same page, and things orchestrated in just an easier, simpler, less restrictive way.
So you've got here the key metrics for a successful deployment. So what are we looking at when we're defining the success and defining the metrics that we want to collect and decide what is of interest and what we need to focus on?
Well, so I really didn't come up with these, but there's sort of like two groups that where they're coming from is the State of DevOps report from DORA. I think it's also run by Google Services now. And there's a 2019 version. I'm most familiar with the 2018 version, which is where a lot of the stuff is coming from. But the 2019 is pretty similar. But really, there's sort of like two spots of development: throughput, which is like how much can we actually get done, and then stability, which is like how, generally speaking, like how how stable is our code? How infrequent are the errors and the issues that we run into? So with throughput, there's sort of two concepts that we can look at, and that is, what's the lead time? So how much time does it take for a concept to be had and then all the way delivered to the customer?
So does that include like before development even starts?
Yeah, absolutely.
So it's not just dev and ops.
Correct. It's all of the software development lifecycle is actually what we're talking about when we're talking about dev development is just the development side, and then operations is really just the running side. So the software being developed and the software running and executing. And a lot of times, I think, like going back to that definition, a lot of people really focus on that trade-off, the handoff between, and I think that is a super critical point. And when we get down a little bit later, we'll look at there's a lot of technical practices that are where the focus of the handoff between development and operations, which is basically that deployment. That is oftentimes like the major focus around DevOps, but really we're talking about the whole life cycle of development and the whole life cycle of operations.
Yeah, and you, excuse me, you mentioned the State of DevOps report, and I know that they do a lot of research into various types of organizations and do a lot of digesting of the information to group those types of organizations into different groups of performers about how well they're deploying and how often they're deploying, right?
Yeah. So they basically come up with about what I call 4.5 groups. There's the elite performers, the high performers, the medium performers, and the low performers. And there's another group called the misguided performers, and they're basically just low performers. But kind of looking back at some of those metrics, there's the lead time, the deployment frequency. Deployment frequency is like how frequent can we actually get code out. Those are all part of throughput. Stability has change failure, which is like how frequently something fails when we deploy it. Time to restore is like how quickly can we like actually recover from that fix, either the fix or the revert. But the elite performers, they are able to sort of deploy on demand. So you look at their like deployment frequency, it's probably like multiple times a day, or just pretty much any time they want. Their lead time is basically under an hour. So someone comes up with some concept they want to try out, and they can pretty much be testing some variant of that within an hour. And I think there are some caveats here, but and then their time to restore is also within an hour. So whether or not they're pushing out a fix for something that they just broke, or whether they're being able to revert right back to where they were, that they could get that done within an hour. And then they fail somewhere about 0 to 15% of the time. Their deployments actually break something. The high performers are really, really, really close to the same. Medium performers, they sort of are in that middle section where they have very similar failure rates, but they're deploying within the week, sometime within the week or within the month. And their lead time is usually about a month to a week, about the same as what you'll notice is that the lead time, that the deployment frequency, when you have a really fast deployment frequency, is the deployment frequency is actually faster than your lead time. But then as your lead time grows, because you have such a long, or as your deployment time grows, your lead time becomes basically your deployment time. So it takes your entire lead time to be the next time. So we work everything in these huge batches, as opposed to like having something in the pipeline constantly being worked on. That's one thing that I kind of noticed. And then the low performers, they're like deploying maybe once a month or longer, and then their lead time sometimes is as much as like 6 months out. 1 month to 6 months of lead time. And their failure rate is like significantly higher. So their failure rate is like somewhere between 46 to 60% of the time something that they're doing is breaking. And part of the problem with that is, or part of the reason why that is that they've had so much time to accumulate the changes that they have, that the things that they're pushing out are such big, they're such large impactful deployments that they're creating a lot of issues, or there's more likely that something, someone forgot about something, or it just stepped on something else, someone else's toes.
Yeah, these days I work with a lot of companies that seem to be in the medium high and maybe even elite performers, but it seems like years ago it was much more common to have those low performers and misguided performers that, every time we turn around, if we try to deploy something breaks, something fails, we have to immediately roll back. We're in on nights and weekends trying to troubleshoot deployments, trying to get code pushed out. So how have things changed, or how can companies improve? How do we improve the processes?
Well, I think that there's obviously the three ways of DevOps, which sort of was introduced in the DevOps handbook by Gene Kim. And the first way, this is sort of like an abstract way of thinking about the work that you have, and it sort of gives you an abstract methodology to tackle the problems and ways to improve. So it doesn't give you any specific things, but it gives you sort of like an abstract way of sort of approaching the solutions. So the first way is sort of what I call systems thinking, and this is sort of understanding the systems that are involved in your workflow and seeing that the workflows in a downstream direction. So you have to understand sort of how the work is flowing from one group of people to another group of people to another group of people to another group of people, and seeing that and making sure that those trade-offs and that there's not sort of bottlenecks happening and forming in one group or one handoff, so to speak. So it's really just basically seeing the systems that are involved and trying to say, how do we optimize the flow through those systems to make sure that work continuously moves.
So
the second way, yeah, go ahead.
Well, you can go ahead and do the ways, but I sort of, something hit me while we were talking about the different performers. The lead time of less than an hour for the elite performers, I mean, they can't possibly be delivering an entire new page on their website or an entire new full API in that hour. I mean, these things take some time to develop. So it feels to me like the big difference. I mean, so the low performers all the way up to the elite performers could have the exact same systems from an operations standpoint. They could have automatic deployments. They could have, all these other things. But the elite performers have managed to shrink their concepts down to a point where it's not, we're going to make a new page. It's, I want to change the way this text box looks. So they just change the text box, and boom, now they have a new widget that they can use, and that can be deployed immediately. And so they must, at some point, they're taking, like, we'd like this new page, but what's the smaller part that we could work on, that we could just get out there, that maybe we could take advantage of sooner? And I don't, in any of the stuff I've read or listened to, I don't think anybody's really talked about having smaller ideas.
Yeah, no, I think that's a pretty good point. That's sort of why I said there's obviously some caveats here, because that's actually the lead approach to product development, is to reduce those idea concepts down smaller and smaller and smaller. So you have small batches that are getting released frequently, as opposed to larger things. And I think probably that's really the main difference between the high performers and the elite performers. The high performers are probably doing a little bit more bigger chunks than the elite performers, and they're maybe deploying an entire page, like you said, versus the elite performers are working on that one part of a page. and getting that out there. The other thing is I think the elite performers, in their breaking down chunks, I think sometimes they'll get the code out there even though it's not necessarily ready entirely. So they'll be using things like feature flags or partial really A/B testing and that sort of thing, where they can begin testing that feature with production code even before it's really fully done.
Yeah, that's a good point, because a lot of the excuse me, a lot of the problems that I experienced in my career early on those larger projects and older projects, quite frankly, were as a result of the process with which we developed and packaged the software. So we would work in a predefined software development lifecycle in 12-week waterfall type sessions, and then at the end of it, try to merge everything together, try to deploy into a QA environment that in no way resembled a dev environment, and then from a QA environment into a production environment that in no way resembled a QA environment. So it sounds like, fundamentally our processes of developing and deploying software have changed.
Yeah, I think that's true.
So with that, I know that you've spent a lot more time doing DevOpsy work most recently. So what are the ways that we can, we started to touch on how to improve and how to structure our code and how to work into deploying those smaller features and smaller subsets. What are the ways that we can achieve that?
Yeah. Okay. So, I think that there are definitely some different technical elements of or technical practices within DevOps that where you find if you know how to do these things sort of well, you'll find that improving the things that you're missing kind of works you towards doing, kind of moving up the rung and becoming a higher performer and working better. So some of those things are one thing is like from a developer standpoint, using trunk-based development. So what this is really working with kind of working off of master. So making sure that everyone knows where the work is going to be coming off of, and making sure that everything that's being developed is being developed off of a single unified branch. This allows there to be a lot faster integration of features into the main master sort of central code. And then a lot of people will do like a release branch, will cut off of that master branch for specific releases. But for the main thing, the significant thing is we're making sure that you're developing on that main trunk. And even if you have to fix something in a release branch, that release branch, you're not fixing it in the release branch, you're fixing it on master and then merging the code or doing like a cherry pick or something like that into the release branch.
So is that different than, I guess, typical development using Git source control, where like you would pull down, clone the master branch, and then you would branch off, do your work, and then create a pull request?
No, that's pretty much. So a lot of people do sort of follow this to some degree, and especially if it's almost if you have like the least amount of process in place, you probably follow a very close to trunk-based development scheme. But yeah, working basically off of master, where you pull down master. A lot of people will create feature branches or something like that, where they'll do all their work in, and then push that up and cut that, in a pull request back over to master. Where it goes awry is where you have people where if you're cutting a release early, so the business is saying, hey, we need to have this release done, so you make a release before the work has ever been done, and then you're doing the work on this release, and then you have another one coming up, so you cut another release to do that work on, but it has to be partly off of it, and you're busy having to like rebase branches to make sure that they stay up to date, or you do things like Git flow, where you have a different long-running branch for every single environment that you have. So you have one for dev and one for testing and one for QA. We don't really want to have different branches for each one of those things. We want the code to be the code. And those will, I'm not saying that those can't work. You can't, it isn't that you can't have good practices and do things well with that sort of style. But it seems like the more efficient, effective methodology is to sort of follow that trunk-based situation.
Yeah, excuse me. I've worked with teams that have tried to adopt Git flow and work in that process, and I'm sure that other teams have been successful. Our success was less so, and caused a little bit more headache than I think it was worth. And I've seen various articles and blog posts in favor and against Git flow. I tend to enjoy the ones against it because it supports my personal feelings. But I've also experienced some troubles with cutting a release branch too early, and then that becomes a new development branch or master branch that is developed from, and then things cherry picked and or merged back into master in various states. So that's a very good point to bring up, to just be aware of that, and don't cut those branches too early, because then you have to develop a whole new release pipeline to be able to deploy that. And I guess that's a good segue and a good topic. What about release pipelines? Where do they come into play there? Do you keep a copy of those in various release branches, or how do you manage that?
Well, so I think actually the release pipelines, a lot of times you can have basically the same pipeline being run in the master or the release, but it'll trigger off of you can like set triggers off of different parts, and you can set stages so that something will skip during a non-release stage, for example. So we may only want to do certain automatic deploying to certain environments because this is coming off of the main master branch. But unless this is a release branch, we want to deploy it into our QA branch or something, or QA environment. But yeah, deployment automation, just having those pipelines is actually one of the technical practices, and making sure that those are available.
And Clayton, you started to kind of address some of the items that being able to deploy things, like if it's just a text change or a small little tiny feature, being able to divide those things up into smaller architectural pieces, work in loosely coupled architectures, maybe more buzzwords like microservices and things like that, right? But that helps divide up those features that they can be developed independently and deployed independently.
So you're saying in that respect, it goes all the way from your basic solid principles all the way up through lambdas and functions, having everything loosely connected so that you can deploy separately and modify separately.
Yeah, let's go with that.
Yeah, definitely moving in that direction for sure.
Yeah, and the caveat, or I guess the converse to that, I've also seen some organizations and some companies and some teams moving towards a mono repo, which I think is kind of the antithesis of that, and then moving all of those features into a giant monolithic repository that houses every single feature and function and application and process and procedure.
Feels like that would be certainly easier to manage, but harder to keep loose.
Yeah, and what I dislike about that is that in reading through the DevOps handbook and at the time that I came across this mono repo that I was on a team working with, it seemed like we were optimizing for development practices, but not optimizing for deployment and delivering of features. So it sounds like we wanted to more, it seemed to me like it might be more prudent to focus on how to deliver features and not really optimize for development speed if we'd cause a bottleneck further down the process.
Yeah, I mean, although so having everything in one repo, I think could be still broken into multiple build pipelines. I've done a lot of this with a couple different repos where you have multiple pipelines all pulling out of the same one, and they just use different file. They're looking for certain files or folder directories to have changes in them to trigger. It is a little bit more complicated, and it probably adds some complexity, but it is still possible to sort of get that good separation.
Yeah, you just have. I was going to say, you just have all of your applications on a different branch in that repo.
No, that's a bad idea.
No, you don't.
So that's not trunk-based development.
Yeah, I would say it's certainly possible, but it does absolutely increase a little bit more. It increases the complexity in your build processes, in your release processes, in your YAML files or whatever you're using, right? And so then it becomes there. It's no longer just a small script for build and release. It's defining your architectures. It's defining the pieces and processes that must go out together. It makes it quite a bit more difficult to go through a particular release and see what was included, because if someone has to look at the last change set and sees 40,000 files changed because of that typo that was changed because that was the last thing that got merged in, that makes it's a little bit of give and take. So you have to evaluate that, and if that meets your needs, go for it. If that's what will help you deliver value faster, then absolutely go for that.
No, I agree with that 100%. I've seen, so I think the biggest thing you hit on there is there's a give and a take here, because I've seen it go the other direction where everything is so split out that we had so many different pipelines triggering other things that you created a nightmare just trying to figure out what all is actually being done here. So
yeah, it sounds like maybe there's a little bit more addressed. You need to address the coupledness of the architecture at that point if everything needs to be triggered at that point, right?
Mm-hmm. Yeah, so we kind of touched a little bit on this already, but continuous integration continuous integration is sort of trunk-based development really enables a lot of continuous integration, but continuous integration is really making sure that we are constantly bringing those features that we're building back into the code, and that code is being updated with the new features. And having an automatic build, having an automatic integration environment that we can deploy to, and having smoke tests that are available, that really defines sort of what a good continuous integration looks like.
Yeah, I was going to say continuous integration is a must-have if you want to have the high deploy counts, right? I mean, you can't. Yep. It'd be almost impossible to do manually and have 100 deploys a day. There'd just be some DevOps engineer sitting in the corner just hitting the deploy on.
Yeah, that sort of brings up continuous testing, and a lot of. So when we're talking about moving more rapidly, we really need to emphasize that most of your testing needs to be properly balanced. So there's the sort of triangle of proper testing where you have the base is automated unit tests, and then next level is functional or automated integration tests, and maybe the next level is like functional and API testing or something like that. And then the very top, the used sparsely part of the food pyramid is manual QA is actually going in there and testing something manually. And so making sure that you can have those tests written and that they can be integrated into build pipelines, that can be integrated into the deployment pipelines and release pipelines, that is critical to being able to move through that system very quickly.
Yeah, and next on our list is monitoring and observability. I've been speaking on logging and metrics in .NET Core recently, and have really been enjoying using application insights and Azure Monitor and a lot of logging with things like Log and things like that. So I really enjoy dashboards and things like Grafana and really seeing how the application's being utilized, where any potential bottlenecks are, if any errors are occurring and where they might be occurring. So I think building that type of information into the applications we build and utilizing the tools that can collect it and show us how the applications are performing are just vital so that we can understand the health of the applications.
Yep, these are some of the critical things to that second way, which is amplifying and shortening the feedback, basically getting that downstream info so that we can use it to effectively determine what the upstream work is supposed to be. And without monitoring, good monitoring, it's no use.
What about managing database changes? I've been working with a project recently that is very database centric. There's a lot of databases. There's SSIS packages. There's analytics. There's logic apps and Azure Data Factory. How do we manage those changes for our database schemas and the like?
I think that managing database changes is one of the most difficult parts, quite frankly. And I think I don't know that I have the perfect way or can necessarily point people in the right direction, but I do think that using something to help update your schema automatically, we have an internal tool that we use to update those things, but you could certainly use like migrations. Basically also making sure that the changes that you're making are like only additive and not removing data. So you migrate columns. If you need to change it, you don't remove them from the old stuff. And there's a couple like sort of things like that you can do to help sort of enact those changes and make them automatically. And then developing in such a way that you don't have to revert database changes, because reverting database changes are some of the more difficult ways of dealing with that.
Just restore from backup.
Yeah. I did have to do that the other day, actually.
You're not supposed to admit to those things.
It wasn't that big of a deal, but
It's just the entire production database. It's fine.
yeah, exactly. Well, it was a production database, and
It was a small production database. It's fine.
So moving on before Ash gets fired.
In this case, our managing database changes weren't so well notified or looked at on our side. We included some data manipulation into the changes that were going, and so someone missed that in a code review, so we pushed it out, and all of a sudden we cleared out all of the production users.
Oh, little Bobby tables.
Yeah, but think about the storage space you saved.
But fortunately, it's a low-use application, and no one was screaming at us, and I was able to restore it because we have backups, and that we were able to restore it very quickly.
Well, it's good to know the backups work.
No big deal. See, it's part of that time to recover. Even the elites, they cause failures, 15% of the time. So.
And how do you know your backups work if you don't actually use them, right? You have to test them.
It's actually really true. A lot of people do set up backups and then they have no idea how to actually perform the process if they've never done it. So, the last thing is is really focused on security, and there's proactive and sort of reactive And the main thing is to have that all integrated into your development process. The proactive side is where you're able to set up sort of security testing, maybe using something like Zaps or whatnot, where you actually have something kind of continuously testing, or you can maybe do some code scan. I can't remember what it's called, but which is like scans your source code to look for common security issues in your build process or something like that. But then the biggest thing is reactive. On the reactive side, when you're able to identify the security pieces, how quickly can you actually get the changes made and pushed through your system? Sort of having all of those other good technical practices allow you to quickly push out security fixes, so that you don't have to be waiting for the next 6 months, for that release to actually get that out.
And starting to wrap up here, I've read various kind of clickbait type articles or clickbait headlines saying things like DevOps is replacing Agile, or DevOps is eating Agile, and Agile is no more because we have DevOps. What are your thoughts on that?
My thoughts are DevOps is just an extension of Agile. And if you think of what Agile was, they said we want to focus on individuals and interactions over processes and tools, right? Think about the Donovan Brown's, he was like, right, we want to have a union of people, processes, and technology. We want that union, everyone to be on the same page, but we want that order to be in the right order. Working software over comprehensive documentation, right? The focus is on delivering customer value, and customer collaboration, again, over contract negotiation. That's also basically saying we want to look at and focus on the customer value. If we're not collaborating with our customers to know what actually works for them, and that also sort of goes to looking at the feedback loops and the monitoring. Hey, what are people actually doing? What are people actually using? What works for them? And then responding to change over following a plan. DevOps is definitely about having plans in place, but it's plans in place so that you can change. It's making sure that all of the steps that you can do to enact a change are set. We want to have plans so that we can respond to things in the best way, and that's really what DevOps is a lot about. So I just think it's sort of an extension of Agile. It's very, very much one and the same mindset.
All right. So what if people are interested in learning more about DevOps? Are there any particular resources that you might recommend?
Yeah, I got a bunch here. I think it's not probably the one that is the best, but the MS Docs over at docs.microsoft.com. What is DevOps? I think it's a pretty short read and is a really excellent. It covers a lot of things very, very nicely. The two novels by Gene Kim, The Phoenix Project and The Unicorn Project, are absolutely fun. They're fun reads and they're exciting, and they do a great job at showing the DevOps practices without really being a giant technical book. But if you are looking for that technical book, the DevOps Handbook is definitely the one to go to, by Gene Kim and Jez Humble. And then there are lastly two things. There's the Accelerate 2019 State of DevOps Report by DORA, which is like the DevOps Research Association or something like that, and Google Services. We could put that link in the description. And then Puppet also came out with their own State of DevOps report, which is a little bit more focused on security and other stuff. It has some differences, and I highly recommend it. And then I also mentioned Zaps, which is a OWASP product for doing security testing.
All right. And with that, dear listener, we'd like to hear from you. Let us know how you are doing DevOps. Tell us what is working for you and what is not working. Do you have any more questions? Don't forget to reach out to us on Slack.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.